5. Don't need the negative because it's a length. Length is neither, it's positive. What's this length of line? 12. And now, what do we have to do to find that hypotenuse? Pythagorean's theorem. So a squared plus b squared equals c squared. So we're going to go 5 squared plus 12 squared equals c squared. So 25 plus 144. So it'd be 13?
Yep.
And now we're ready to do sine all 6 trig functions. Are we good to go?
Yep, you're recording.
Good, thank you. So sine of the angle, and the angle is always coming from the origin, is what's opposite of that? What's opposite of that angle? Over what's the hypotenuse? What's the cosine of that? It's adjacent, so what's next door? That's what adjacent is. And then tangent is opposite over adjacent. And if you know these 3, then you know these 3, because all you got to do is invert them. And what quadrant are we located in? So all students take calculus. So in the second quadrant, what's positive?
Sine.
Sine. That means these 2 are positive. Everything else will be negative. So the very first step you do in given a point, find 6 trig functions is to plot the point. Connect the point to the origin and the x-axis. Complete the triangle using Pythagorean's theorem. Then you state by the definition of trig, sines opposite over hypotenuse, cosines adjacent over hypotenuse, and tangents opposite over adjacent. Then the other 3 are just the inversion of that. And then you say what quadrant it's in. And whatever quadrant, you have to put the correct signs, S-I-G-N, on that value. Is everybody good on that example?
Yep.
Okay, the next, there are 4 reference angles. You've got to be able to state the quadrant, the reference angle, and the exact value. And this is where you want your trig information sheet out. So if I want, let's say I want the tangent of 225 degrees. That little chart can help you find the reference angle. Which you could put that on the very front page of your trig information sheet, because I already have all students take calculus labeled out there. And you could put that little information on it so you have that already noted. So where am I located? Where's 225 located? What quadrant?
Third.
Third. So that's the first thing you want to do is tell me it's the third. The reference angle, to find the reference angle, you take it, subtract 180. So what's 225 minus 180? 45, so that's the reference angle. Now, what will be the exact trig function? You can turn to the flip side of your trig information sheet, and doesn't it have the chart on there for 45? And it is 1, right? And now, what quadrant are we in? So what's tangent in the third quadrant? So this is a positive one, and I'm just putting that positive there to emphasize that I did check to see what the sign was going to be. The S-I-G-N, that is. Okay, this time I want the secant of 120 degrees. So 120 degrees, what quadrant are we in? Second. So to find the reference angle, we take, it's in the second, so it's 180 minus it. So what's 180 minus 120?
60.
Now use your chart. What's the secant of 60? It's 2. And what quadrant are we in?
The second.
And what's the secant in the second? Only the sign, so this would be negative. So everybody follow what you're doing on exact trigs.
Yeah.
So quadrant, reference angle, get your value, and then make sure you put the right SIGN on your answer. The 4 calculators, it's just using your calculator. Make sure you go out 4 decimal places. So I've got a few examples up here that you can practice on your calculator and make sure you can get those values. Now we're ready for completing the triangle. Using log sines or log cosines, which you should have those formulas in your notebook. But on this one, what's given to us? 3 sides, so that means you've got to use law of cosines. And here's something that you may not, or may have it written there somewhere, but if you're using law of cosines, it's side, 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 or side, angle, side. You use law of sines when it's angle, angle, side, or side, side, angle. So those are when you use what first. So in this case, we have all 3 sides, so I want to use law of cosines. And we want to find an angle. So cosine of A, I always find the one that comes alphabetically first, is A squared, I'll write the formula first down, minus B squared minus C squared over a negative 2 times B times C. And whichever side or angle you want, you start with that side first and then subtract the other 2. And basically it's just use of your calculator once you get to that point. So in this one, what's side A? It's 13 minus B, so 12, minus C over negative 2 times 12 times 14. Now we're ready to go to your calculator. Is everybody ready?
Yeah.
Okay, to enter this in your calculator, you put 13 squared, subtract 12 squared, subtract 14 squared, hit equal, because you're at the end of a line. Then, now this is where I might do it different than other people do it. I always do my calculator with the least amount of keystrokes, so I have the least amount of effort. So I'm going to divide by each one of these numbers, instead of putting into parentheses, because that's 2 extra keystrokes. So I divide by a negative 2, I divide by 12, and I divide by 14, and I hit equal. And then hit equal, because you're at the end of a line. Now, you should have an answer, but you want an angle. So to get an angle, you hit second cosine of the answer. Those of you who have the answer key. Delaney and Delaney, you don't have an answer key, so you just hit second cosine, and it gives it to you.
If for the denominator, can we also just do negative 2 times 12 times 14, or is it?
But it has to be in parentheses if you're doing that, because you want to make sure it does the operations correctly. That's why I go divide by negative 2, divide by 12, divide by 14. Now, does anybody have, and then you got to hit degrees, minutes, seconds to change to degrees, minutes, seconds, because you're rounded to the nearest minute. Does anybody have an answer yet?
59.24.
59.24?
Yeah.
We'll see if anybody else gets that. I
Yeah.
get 2.
Mine says error. I don't understand this yet.
You just hit 13 squared minus 12 squared.
Yeah, so I got negative 1.
Then divide, you've already multiplied it, divide it by negative 336. You're doing all the work. I just have my calculator do all the work. Hit equal. Now you hit second cosine. And then degrees, minutes, seconds on yours is that key. 59.24. Does everybody agree with 59.24? Did you get it?
Yeah.
Did you get it, Delana? Now, if you want to do it where your calculator does the work for you, you just enter it as I said. You go 13 squared, minus 12 squared, minus 14 squared, equal. Divide by negative 2. Divide by 12. Divide by 14. Hit equal. Now, second cosine, because you want an angle, and degrees, minutes, seconds. Anybody else? Because we're going to do it again. Because don't we have to find another angle? Yes? So I'm going to find angle B now, so we've got another practice at it. So to find angle B, it's B squared minus A squared minus C squared divided by a negative 2 times those second 2 numbers. And it's always the second 2 numbers that are on the bottom. Now, somebody want to put it in their calculator. I want more than one so we get the same result. 12 squared minus 13 squared minus 14 squared. When you get to an end of a line, you hit equal. divided by -2, divided by 13, divided by 14, hit equal. And then it's always gonna be second cosine of your answer, degrees, minutes, seconds. Anybody got it? Tara, what'd you get? No?
Error.
Okay, I tried again then.
About 48.52.
48.52. So again, to enter that in a calculator, you go 12 squared minus 13 squared minus 14 squared, hit equal. Your calculator can do all the work for you if you know how to use your calculator. Divide it by a -2, divide it by 13, divide it by 14, hit equal again. Once you hit equal, then you want to find an angle, so it's second cosine of your answer, and then degrees, minutes, seconds.
I got 90 degrees, 6 minutes.
I got 52 degrees 37.
That's what
I
I
did
got.
too.
52.37?
Yeah.
52.37?
Yeah.
Let me follow you through it. No, you just do it.
I just did a long process.
12 squared minus 13 squared minus 14 squared equal, divided by -2, divided by 13, divided by 14, equal, second cosine of your answer, and then degrees, minutes, seconds once you get finished with that.
Okay.
You're gonna get it now. Yeah, clear. Started fresh. You know, just as I said.
So you will be-
As it's written is the way you're writing it. That's all it is. 12 squared minus 13 squared minus 14 squared, hit equal, because you're at the end of the line, divided by -2, divided by -2, divided by 13, divided by 14. You don't have to hit equal till you get to the end of the line. The calculator knows the order of operations. Hit equal. Now you go second cosine of your answer, hit equal, degrees, minutes, seconds. Okay, 52.37? 52.37 is what it should be. Okay, now, while everybody's making sure they can use that, or if you need help with that later, I can help you. But we need to add these two angles together, right? And subtract from 180 to find the third angle. So I have 59.24 and 52.37. I like the good old fashioned way. 1161 is what I got. And you can have, anytime you got 60 minutes or more, don't you have to make that another degree?
Oh, yeah, 11201.
So that would be 11201. Because that 60 moves over and makes a degree. Now I need to subtract that from 180. And when you borrow from it 180, you're borrowing 60 minutes. And I get 67.59.
Yep.
So you add the two angles together that you have given to you and subtract from 180 to find your third. Anytime you have two angles, you add them together and subtract from 180. Okay, so you're completing a triangle. That one we use totally law of cosines. Could we have used law of sines?
Yeah.
Once we found angle A, we could have used law of sines, which law of sines is the A over the sine of A equals B over the sine of B equals C over the sine of C. You guys recognize that formula? And then you could have cross multiplied and solved and came up with the same result. Now, there's one problem that you have to find the area of a triangle, and Hero's formula would be applicable to the one I have up here, because I have all three sides. Or you could also, since you found an angle, couldn't I also use this formula? So I thought we'd do both, because you get a choice. You can use whichever formula you want to. But if I were to use Hero's formulas, that's where you add the sides together. So it's 1/2 times, what are my sides? 12, 13, and 14. So what's that add up to be? 12 plus 13 plus 14. 39? Now what's half of 39?
19.
18.5, so that's the S.
19.5.
19.5.
Do you have to use the SSS formula or can you?
No, I said you could use either.
Okay.
Okay, so now I know what S is, I put it into this formula. And again, I'm one of those people that, you got a calculator, use the calculator. The calculator can do the work for you if you know how to use your calculator. It's the square root of 19.5 parentheses 19.5 minus the first side, parentheses 19.5 minus the second side, parentheses 19.5 minus the third side. Once you hit equal on that one, then you can square root the answer. And which I'd probably say the square root for the end, because some people may make mistakes typing things into their calculator. But it'd be 19.5 times parentheses 9.5 minus 12 times parentheses 19.5 minus 13 times parentheses 19.5 minus 14. Hit equal and square root your answer. Now, or you could do the work yourself. I don't care. 19.5 times 7.5 times 6.5 times 5.5, multiply it and then square root it. So you can do either or. Use your calculator or not use your calculator. It's up to you there. Now, has anybody got an answer yet?
Just half 39.
That was what this was. This is the area right there, that formula.
Oh, okay.
Did you square root it yet?
Yeah.
We'll see. Anybody else? 72.307? Sounds like if there's a calculator left, I could find out. 19. I get 72.308.
Yeah, that's what I have.
So the area of this one would have been 72.308 units squared. Okay, now, you could have also found it using the other formula. So we have that formula here. It's where you go 1/2, and I'd use 0.5 since you're using your calculator, times two sides that the angle's between. So I'd use 14 and 12. And then times the sine of the angle that's between the two, 59.24. Okay, so somebody want to put that in your calculator and find out what it is. Take 0.5 times 12 times 14 times the sine at 58 degrees, 24 minutes, hit equal. And you should have your answer. 24 minutes. Should be pretty close to the same. 72.3. Okay, does everybody follow? You could use either formula, whichever floats your boat, you might say. Okay, now, we're to the point where I took over. You've got two of these, where you state the amplitude, the period, the phase shift, and graph the picture. Now this is where, if you want to dig in your notebook, this is the one you want, because it has all the information on there for you. So we first state what's the amplitude. Remember, the amplitude is the coefficient of the trig. So what's the absolute value of that coefficient of that number? 5. Period is found by taking, look on your information sheet there, 360 divided by the coefficient of the angle, which is 2. Phase shift is the negative c over k. That means you change the sign of this and you divide by the coefficient of the angle. So 30 divided by 2 is 15 degrees. And then we find the increments, which make it easier to graph. Increments are found by taking the period divided by 4. So what's 180 divided by 4?
45 degrees.
This is always the starting point. The ending point is where you add these two together, so that'd be 195. So So we're starting at 15 degrees and we're adding increments of 45.
And where'd you get 45 at?
You find the increments by taking 180 divided by 4.
Okay.
It's your period divided by 4, which that's also on that instruction sheet. The amplitude on this is 5. And what does a cosine curve look like? Should be also on that paper.
Hi, that's right.
Cosine curve, look at this.
It starts at its amplitude, it ends at its amplitude, halfway it's down its amplitude, and it crosses 0 at the quarters.
Oh.
Okay, another one. Let's do the sine now, which probably too will be the sine and cosine. Let's say I have y equals 2 sine of 1/2 x plus 45 degrees. So what's my amplitude? Period, how do I find it? 360 divided by 1/2, that'd be 720. Phase shift, change the sign of the C and divide it by the coefficient of the angle. So that'd be -90.
Yeah.
How do we find the increments?
The period divided by 4.
So 720 divided by 4 is 180. So there's our starting. Where do we end? We add those two together. So we're starting at a -90. You're adding increments of 180. So if I add 180 to a -90, I get 90. Add 180 again. Add 180 again. 450. Add 180 again. 630, and that's where we stop. And its amplitude is 2. And what's a sine curve look like?
Starts at 0 and goes up and then down. and
Right,
then-
0, beginning, middle, and end, goes up, goes down. You got it.
What about the weird ones?
They aren't gonna have a word one. It'll be a basic one, sine or cosine.
Okay, cool.
Okay, you guys good on that one?
Oh.
Yeah.
Next is verify a trig identity. That means what? You make one side look like the
Other.
other side. And it is pretty basic, I'll tell you that.
Oh, gosh.
It's gonna be easy stuff.
I said basic.
Yeah.
Which side are we gonna work with?
The sign.
The one with the most stuff, the left side. So wouldn't we FOIL that?
Yeah.
So we end up with first times first, the inner and outer cancel, and last times last. What's 1 minus sine squared?
Cosine squared.
Okay, are we good on a verify?
Oh.
It is very basic. There's not much to it, other than know your 8 identities there. Solve a trig equation between 0 and 360 degrees.
What's this one under?
Solve a trig equation. What would I do first? Get it equal to 0. And then use the quadratic formula.
And cosine.
So you're solving for cosine. Of course your trig has to be in terms of the same trig. You know, if I had 2 sine squared in here, I would change sine squared to 1 minus cosine squared, and then do the same process, which we could do an example of that if you want.
Yeah.
So cosine equals the opposite of b,
5.
plus or minus b squared,
25.
minus 4 times a times C over 2 times A. So what do we get underneath the radical? 8, 24, 49? The square root of 49 is?
7.
So 5 plus 7 is 12. 12 divided by 3, 12 divided by 4 is 3. 5 minus 7 is a negative 2. Divided by 4 is? Now, what's the reference angle for where cosine is 3? It doesn't exist because remember cosine and sine have to be between 1 and a negative 1. So this one there's no answer on. This one, you'd look on your chart, well, where is the reference angle for 1/2? So where's the cosine of half? 60 degrees. Where is the cosine negative? What quadrants?
Second and third.
Second and third.
And then we do the.
So to place it in the second, I add it to or subtract it from 180, so it'd be 120. In the third, you add it to 180, so that'd be adding 60 to 180, so I get 240.
Yep.
So 240 and 120 would be our answers.
Lit. Next.
I'm gonna see where you're going, Lily.
Thanks, Promise.
Okay, do you guys need another one there, or are you okay on solving?
I was like, same.
1, given a trig value, complete a triangle, and then find the sine of a double angle. So you need your sine of a double angle formula.
Isn't that on our page?
It's on your trig information
Sine
sheet.
2A equals 2 sine A equals sine A. Are the sine of 2x and cosine of 2x much different?
They're the same, basically, except
Just
one's
different
doing the
formulas.
cosine. So I really could say this and this, because it's really doing the same process. Let's say that x is in the second quadrant. Okay, so the first thing you have to do is to set up your triangle. So what's cosine by definition? Adjacent over hypotenuse. So then we have to use Pythagorean's theorem to complete the triangle. So 12 squared plus b squared equals 17 squared. So b squared equals 145.
Yes.
And now we square root it. So b equals the square root of 145. We're in the second quadrant, so remember that.
What's b squared equal?
145, square root of 145. Now you just write down the formula. If it's the cosine of a double angle, you'd write down the cosine of a double angle formula. If it's the sine, you write down the sine. So I'm asking you to find the sine of a double angle. Here's the formula for it, right? So it's 2 times, what's the sine of this angle? Opposite over hypotenuse. And it's in the second quadrant, so the sign, S-I-G-N, is positive. What's the cosine of this triangle? And it's negative because it's in the second quadrant and it was cosine. Then all you do is multiply. So I get a negative 24 square roots of 145 over 289. And that would be your answer. Now if I ask for the cosine of a double angle, what's different? Use a different formula.
Yeah, there's different formulas.
So if I want the cosine of a double angle, there's 3 formulas to choose from. You want 1 minus 2,
Sine squared.
so, and now you could use 2 cosine squared minus 1, or you could use cosine squared minus sine squared, either works. So this would be 2 times, what's the sine of that triangle? Square root of 145 over 17, and I got a square. So I got 1 minus 2 times 145 over 289. So 1 minus, what, 290? If I take 2 times 145, is that right?
Yeah.
And now what's 1, subtract that, would be a negative 1 over 289?
Yep.
Does everybody follow what we did there? So just pay attention to which one it asks for.
So we do sine, cosine, and tangent?
No, you're only doing one.
Okay. So
You'll
that's
either do the
easy.
sine on one or the cosine on one.
Okay.
Did we choose the only one to do?
No, it tells you which one to do.
Oh.
One change, okay, now we're to the stuff that you guys should be quite good at.
Yep.
Recent stuff?
Recent stuff.
Oh.
One where you're changing polar coordinate to rectangular coordinate. So that's r theta. You want it changed to rectangular coordinate. Well, x equals r cosine of theta, y equals r sine of theta. That's the formula. So if I have 3 50 degrees. To change it to its rectangular, it would be x equals 3 times the cosine of 50, so I need somebody with their calculator skills. No, it's just equal, it's a decimal.
Oh, 1.928.
9283. Y is equal to the sine of 50 degrees,
2.2981.
2.2981. So our answer is 1.9283, comma 2.2981.
Well, how do you want us to round them?
Probably nearest hundreds.
Mr. Hurley, please buzz the office. Mr. Hurley, buzz the office.
But I just did the whole thing, so you got enough to look at. Let's see, you're changing, that was the first of that group. One change rectangular to polar. So that means you're going x comma y to r theta. So on this one, the formula is r equals the square root of x squared plus y squared. And theta is equal to the arc tangent of y divided by x. But if x is negative, you have to add 180 degrees. You guys remember that?
Mm-hmm.
So let's do a point that's 2, 5. Okay, so r is going to equal the square root of 2 squared plus 5 squared. So that's square root of 29. Theta, you guys need your calculators for this. It's the arc tangent of y divided by x. So 5 divided by 2, and then you need to change it to degrees, minutes, seconds.
6812.
Yeah.
So our answer is the square root of 29, 68, 12. And that was found by taking 5 divided by 2, hit equal, second tangent of 5 divided by 2, and then degrees, minutes, seconds. So very good there.
Yep.
Yeah.
Complex to blah blah blah. So blah blah.
Okay, complex to, r cis theta. So that's a plus bi to r cis theta. Essentially, the formula is the same. You guys found that out. That's a squared plus b squared equals r under the radical. Theta is the arc tangent of b divided by a, but if a is negative, you add 180. So if I have the negative 3 plus 4i, for instance. R is going to equal the square root of a negative 3 squared plus 4 squared. And I remember some people on their test missed this last time because they told me a negative 3 squared was a negative 9. Remember, if your calculator, which most of you have that reverse polar calculator, you have to put negatives in parentheses so it does the work for you. Otherwise, use your brain to make sure you get the negatives done correctly. So that would end up being 9 plus 16, and that would be 5, right? Now, theta is going to be the arc tangent of 4 divided by negative 3. Notice I gave you a negative, so what do you got to remember to do? Add 180. So you're going to go second tangent, 4 divided by negative 3, hit equal. Add 180, and then degrees, minutes, seconds. What'd you get?
126.52.
146?
126.
126.52?
Yeah.
So it's 5 cis, 126.52 for an answer. Do we agree on those values?
And then the opposite.
Now it's the opposite.
Polar to complex.
And remember, that is just, all you do is distribute. But be careful if your calculator, I think I did degrees, so you don't have to worry about that. So r cis theta has to be changed to a plus bi. Remember, what does r cis theta stand for? R times the cosine of theta plus I sine of theta. So r times the cosine of theta plus I sine of theta. And all you really do is distribute to get your other answer. So if I give you 2 cis 30 degrees, which I'll write it the long way too and expand it, so it'd be 2 cosine of 30 plus I sine of 30. So all you gotta do is distribute 2 times the cosine of 30 is
1.73i, and then the 2 sine of 30 is 1.
okay, so this should be 1.73, right?
Yeah.
And this should be the 1i, right? Or you could have used the sine of 30 is the square root of 3 over 2, so the 2's would cancel and I'd get the square root of 3 plus 1i. And either one of those would be the same thing,
Sweet.
if you use your chart. Next,
You don't have to do that.
What was the next one?
product. Find the product and write the answer in both complex and r-cis form. So let's say, is it okay if I write it in the cis form and not the expanded form?
Yes.
So if I have 2 cis of pi over 4 times 3 cis of pi over 3, what would I need to do first?
Convert from radians to degrees.
Convert from rads to degrees, so I multiply by 180 over pi, so this one's 45. 180 over pi, so 60. So now, in a product, you multiply the r's and you add the angles. So 2 times 3 is 6. Cis, if I add the angles, what's 45 plus 60? There's your first answer. How do I get the a plus bi answer? Distribute. So somebody tell me what you get on your calculator. What's 6 times the cosine of 105?
It's 105, not 150. Negative 1.5.
45 plus 60 is 105, isn't it?
Yeah.
Negative 1.56.
Negative 1.56. What's 6 times the sine of 105? It'd be positive. Next one should be positive.
5.7, wait, no, I don't know. I got it, but I don't know how to round.
5.0?
5.82.
5.80? Anybody else get that?
Yeah.
And the first one I got negative 1.55.
Okay.
I have no idea.
Are we agreeable there?
Yeah.
So you have 2 answers. You've got the r cis theta answer, and then you have the a plus bi answer. Next, ordered pair performing operations indicators. If you guys missed these, this is what you just finished.
Oh, yeah.
I got this.
So if I said vector u is 3 vector a's minus 2 vector b's.
So you times the A points by 3. So you get 9.4 and 21.
And then you take the b points times the negative 2 and add.
So 4, like 4.
Now what do those add up to be? 13.
22
Okay, are we good there?
Yep.
What's next? Was it find vector AB
Yes.
and magnitude?
Yes.
Okay. Okay, so what would vector AB be? -3 subtract 5, remember it's always the second one, subtract the first one. 7 subtract a -2.
9.
Magnitude is the distance formula. So I get 8 squared and -9 squared. 145? Is everybody agreeable there? Well, that's as far as we're gonna get. Well, it looks like you just have a couple and you should know how to do an inner product and a cross product. And somebody turn the video off on the way out.
Carissa Hopkins to the office, please. Carissa Hopkins to the office.
Do not do that.